Freshies! Welcome back to another episode of Learning Mathematics here at DepEd TV. I am Teacher Belle, ang iyong kaduo sa Math 7. This is a new day for fun and exciting learning in mathematics. Together, let's be Math Tibay, Math Talino, and Math Galing! Mathematics can be challenging, but it can also be exciting. Discover new topics that are amazing. You can surely enjoy this thing. Be Math Galing, be Math Galing. You can surely enjoy this thing. Now prepare your pen and self-learning module as we explore the fascinating concept of estimating square root of a whole number to the nearest hundredths. Before we start our lesson, let us check if you already mastered the lesson in the previous episode. Let us have a real quick review. You have 5 questions to answer. For each question, you will be given 5 seconds. Are you ready? In this activity, you are going to give the square root of the following. So let us begin with number 1. Square root of 25. Timer! The correct answer is 5. Number 2. Square root of 169. Timer! The correct answer is 13. What if you were tasked to estimate the square roots of numbers which are not perfect squares? What will you do? At this point, we are going to start the discussion on estimating the square root of a whole number to the nearest hundredths. Are you ready? Let's get started! When finding a square root of a number on a calculator, you may notice that the answer may be a rational number. But for numbers which are not perfect squares, you will see several digits after the decimal point. This means that the answer is an irrational number, which cannot be expressed as fractions. To determine the approximate value of the square root of a number that is not a perfect square, a series of estimation is made. We can follow these steps. Step 1. Find the perfect squares less than and greater than the number which are closest to the given number. Step 2. Make an educated guess to one decimal place and try it. Step 3. Decide which is closer. Let's take a look at these examples. Estimate each square root to the nearest hundredths. Number 1. Square root of 7. Number 2. Square root of 263. Number 3. Square root of 73. For number 1, we know that 7 is not a perfect square. So let us estimate the square root of 7 by following the steps. Step 1. Find the perfect squares less than and greater than the number which are closest to the given number. The perfect squares closest to 7 are 4 and 9. The square root of 7 is less than the square root of 9, but greater than the square root of 4. Since the square root of 4 is 2 and the square root of 9 is 3, we can say that the square root of 7 must be between 2 and 3. Step 2. Make an educated guess to one decimal place and try it. 4 is 3 units from 7. while 9 is 2 units from 7. From here, we know that 7 is closer to 9 than to 4. So, the square root of 7 must be closer to 3 than to 2. Based from this, we can say that the decimal should be greater than 0.5. Let's try 2.6. If we square this, we will multiply 2.6 by itself. That is 2.6 times 2.6, which will result to 6.76. Now, let us try 2.7. 2.7 squared is 7.29. 7 should be between 6.76 and 7.29. Therefore, the square root of 7 must be between 2.6 and 2.7. Step 3. Decide which is closer. 7 is closer to 6.76 than 7.29. So, the square root of 7 must be closer to 2.6 than to 2.7. For the second decimal place, we can try 2.61, 2.62, 2.63, 2.64, and 2.65, since these values are closer to 2.6. If we square 2.61, the answer is 6.8121. For the square of 2.62, that is 6.8644. The square of 2.63 is 6.9169. We are getting closer to 7, right? Now, squaring 2.64 will result to 6.9696. And 2.65 squared is 7.0225. Which of the results obtained has the closest value to 7? 7.0225. And we know that this was obtained by squaring 2.65. Hence, the square root of 7, estimated to the nearest hundredths, is 2.65. Next example. Square root of 263. Step 1. The perfect squares closest to 263 are 256 and 289. The square root of 256 is 16, and the square root of 289 is 17. So the square root of 263 must be between 16 and 17. Step 2. We know that 263 is closer to 256 than to 289. So, the square root of 263 must be closer to 16 than to 17. Let's try 16.1, 16.2, 16.3, and 16.4. 16.1 squared is 259.21. 16.2 squared is 262.44. 16.3 squared is 265.69. And 16.4 squared is 268.96. The value of 263 is between 262.44 and 265.69. Therefore, the square root of 263 must be between 16.2 and 16.3. Step 3. We know that 263 is closer to 262.44 than to 265.69. So we will try 16.21, 16.22, 16.23, and 16.24. The square of 16.21 is 262.7641. The square of 16.22 is 263.0884. The square of 16.23 is 263.4129. And the square root of 16.24 is 263.7376. So, which of the results obtained has the closest value to 263? That's right! 263.0884. Thus, the square root of 263, estimated to the nearest hundredths, is 16.22. For our last example, let us estimate the square root of 73. Step 1. The perfect squares closest to 73 are 64 and 81. The square root of 64 is 8, while the square root of 81 is 9. Therefore, the square root of 73 must be between 8 and 9. Step 2. If we measure the distance of 73 from 64 on the number line, that would be 9 units, while the distance of 73 from 81 is 8 units. Since 73 is almost at the middle of 64 and 81, we must consider that the decimal part may be 0.5. So we will try 8.5, 8.6, and 8.7. 8.5 squared is 72.25. 8.6 squared is 73.96. And the square of 8.7 is 75.69. The value of 73 is between 72.25 and 73.96. So, the square root of 73 must be between 8.5 and 8.6. Step 3. We know that the value of 73 is closer to 72.25 than to 73.96. So, the square root of 73 must be closer to 8.5. Let us try 8.51, 8.52, 8.53, and 8.54. The square of 8.51 is 72.4201. The square of 8.52 is 72.5904. 8.53 squared is 72.7609. And 8.54 squared is 72.9316. From the obtained results, which has the closest value to 73? Amazing! That is 72.9316. And this was obtained by squaring 8.54. Thus, the square root of 73, estimated to the nearest hundredths, is 8.54. Did you get it? The process in estimating the square root of a number, which is not a perfect square, to the nearest hundredths may seem complicated. But it's easy for our math-galing freshies, right? To summarize what we have learned today, let us reiterate the steps in estimating a square root of a number to the nearest hundredths. Complete the statements below. Choose your answer from the words given in the box. To determine the approximate value of the square root of a number that is not a perfect square, a series of blank is made. We can follow these steps. Step 1. Find the blank less than and greater than the number which are blank to the given number. Step 2. Make an educated guess to blank decimal place and try it. Step 3. Decide which is blank. You have 30 seconds to complete the task. Timer starts now. Time's up! To determine the approximate value of the square root of a number that is not a perfect square, a series of estimation is made. We can follow these steps. Step 1. Find the perfect squares less than and greater than the number which are closest to the given number. Step 2. Make an educated guess to one decimal place and try it. Step 3. Decide which is closer. Great job! I think you are now ready to do this on your own. To measure your understanding of the concept, try this on your own. Let's have an exercise for your brain through Sit in a minute!
Estimate the square root of the following. You will be given a minute to do both items. So, let's start!
Number 1. Square root of 55.
And number 2, square root of 205. Timer!
Let us check if you got the correct answer. For number 1, 55 is closest to the perfect squares 49 and 64, which has a square root of 7 and 8 respectively. It is closer to 49, so the square root may be 7.4 or 7.5. 55 will be closer to the square of 7.4. So we may try 7.41 squared and 7.42 squared. The answer is 7.42. For number 2, 205 is closest to the perfect squares 196 and 225, which has a square root of 14 and 15 respectively. It is closer to 196, so the square root may be 14.3 or 14.4. 205 will be closer to the square of 14.3, so we may try 14.31 and 14.32. The answer is 14.32. Before we formally end our lesson, I am assigning you to do some additional activities on your self-learning module. Please answer what I have learned and what I can do.
That's it for today, but learning does not end here. In our next episode, we will be enlightened on how to plot irrational numbers on a number line. Again, this is Teacher Belle, ang iyong kaduo sa Math 7. I hope we help you become math tibay, math talino, and math